We have spoken quite a bit about linear approximations. Now let us move one step ahead. One step ahead of linear, and by that I mean let's move into the quadratic approximation. Now what happens in a quadratic approximation? Just like a linear approximation, it moves one step ahead of it. It adds a quadratic term to the approximation. So, previously we had, say, fx is approximately equal to fx naught plus f dash x naught into x minus x naught around a certain point x naught. That is, the tangent and the curve are almost same at that point of time and nearby around that point. Now what happens in a quadratic approximation? Quadratic approximation adds another term to it. It adds a term of f double dash into a quadratic polynomial term, f double dash x naught by 2, and we will try to understand in the later video that why I'm putting it as a fraction of 2. So half of f double dash x naught into x minus x naught to the power 2 is our linear approximation, or is our quadratic approximation. So fx is almost equal to this near x naught, okay. Now this additional term f double dash, so the second derivative actually tells us the shape of the curve, and that's what this approximation tells us. It actually tells us the shape of any curve. So for example, let us take a simple example as we did previously also, e to the power 0.1. Now e to the power 0.1 was approximately what? 1.1. Why? Because e to the power x is approximately 1 plus x around 0, of course. Now similarly, e to the power x will be, what will it be as a quadratic approximation? It will be 1 plus x square by 2. Now this x square plus 2 will be a small term because we are around 0, that means our x has to be small. So when I square it, this is a fraction definitely, right? Less than 1. This will be, x will be a fraction which is less than 1. When I square it and half it, it's even smaller, okay. Now how do I get in here? Essentially ex, f dash x is also ex, f double dash x will also be ex. So just directly putting in the formula out here, and let me use another color. So your f at 0 is e to the power 0, it's 1 plus 1 into x plus 1 into x square by 2. So that is how I get 1 plus x square by 2. So that means that my linear approximation for 0.1 will be 1.1 plus 0.1 whole square by 2, which essentially will be equal to 1.105, just a little ahead of 1.1. So that shows us the increasing shape of the function, So this is a 0.1. So somewhere here the linear approximation 1.1 and quadratic approximation that the curve is a little above the linear line. The curve is a little above the linear line, moving in an increasing direction. So that's what is your quadratic approximation.